Good morning, everyone. This is the eighth lecture on rotational motion, and I initially planned on taking 9 lectures, but it looks like I'll have to extend that a little bit because we are doing most of these topics in a lot of detail. In the last class, we did problems on torque and rotational equilibrium. Towards the end of the class, I told you that there is an equation tau is equal to I alpha, and that equation is used to solve problems on rotational dynamics where something is moving. Today's class is about a mix of problems on rotational dynamics and rotational equilibrium, though we'll focus more on problems that have motion aspect to it, problems that are moving. Okay, so let us begin. The first problem I'm going to give you today is a problem on rotational equilibrium. It's a practice problem, give it a try. Let us assume that there is a flat surface. Okay, there's a flat surface and there is a block kept on that surface. Okay, near this block there is a wheel. Looks like the wheel is slightly above the ground. Near this block there is a wheel. Now this wheel is initially resting on the ground. So this wheel is initially resting on the ground, but we are pulling the wheel horizontally with a force F. So what is going to happen when you pull the wheel horizontally with the force F? This wheel is going to turn up. It's going to go over this block. The height of this block is around 20 centimeters. Okay. This distance, the radius of the wheel, is equal to 0.6 centimeters, 0.6 meters, sorry. This distance is equal to 0.6 meters. Okay, that's the distance from this point of contact to this point. So it's not exactly the radius, it's slightly lesser than the radius, and that is equal to 0.6 meters. The radius of the wheel is given as 1 meter. This radius is given as 1 meter. And the mass of this roller is around 20 kgs. Okay, so this is 20 centimeters, this is 0.6 meters, that's 1 meter. The mass of the wheel is around 20 kgs. Your job is to find out what is the amount of force that is required to make this wheel rotate, or to just get this wheel to topple over the block. So find the value of F, find F, for which wheel can cross over the block. Wheel can cross over the block. Try it, pause the video, give it a try. It's a problem on rotational equilibrium because if the value of force is slightly less, the wheel will not move. And if the value of force is slightly more, the wheel will just begin to move, which is almost like staying at rest. So it's a problem on rotational equilibrium. See if you can try it. The good thing about this problem is that if at all the wheel starts moving, this is the axis of rotation because this point cannot move. This point is obstructed by the block. This point cannot move. Literally every other point is going to move, and after some time, the wheel is going to look like this. Okay, after some time, the entire wheel is going to shift forward like this. The entire wheel. So this is what can happen. This is the axis of rotation. So because the wheel is not rotating right now, what are the forces acting on it? The forces acting on this thing are mg, your force, and because the wheel is just about to rotate, it is almost not in contact with the ground, so there is no normal force. Okay, understand this aspect. If you increase the force a little bit, the wheel will start rotating about this point, घूमने लगेगा, ठीक है? तो जैसे ही व्हील रोल करने लगेगा, व्हील जैसे ही इस ब्लॉक के ऊपर आएगा, तो ये नीचे से इसका कांटेक्ट छूट जाएगा. तो कांटेक्ट छूटेगा तो फिर नॉर्मल फोर्स जितना है, नॉर्मल फोर्स यहाँ पे रहेगा ही नहीं. इसके पहले नॉर्मल फोर्स भले हो सकता है, लेकिन अब नॉर्मल फोर्स जीरो हो जाएगा क्योंकि द व्हील इज गोइंग टू क्रॉस ओवर द ब्लॉक. ठीक है, तो हमें क्या करना है, टू सॉल्व द प्रॉब्लम अबाउट द एक्सिस ऑफ रोटेशन, हमें दो टॉर्क्स को बैलेंस करना है। एक तो तुम्हारा फोर्स का टॉर्क और दूसरा तुम्हारे mg का टॉर्क। तो किसी भी एक डायरेक्शन को प्लस ले लेते हैं, फोर्स के टॉर्क को प्लस ले लेते हैं, mg का टॉर्क नेगेटिव हो जाएगा। अब देखो डिस्टेंस कितना है फोर्स का, दिस इज द एक्सिस ऑफ रोटेशन, तुम्हें लेना है परपेंडिकुलर डिस्टेंस। तो फोर्स के लिए तुम्हें ये वाला डिस्टेंस लेना पड़ेगा जो अभी मैं डॉटेड बना रहा हूँ। ये डिस्टेंस कितना है, तो क्वेश्चन बता रहा है कि ये जो डिस्टेंस है ये 0.6 मीटर्स है, तो ऑब्वियसली ये 0.8 हो जाएगा। 6 स्क्वायर प्लस 8 स्क्वायर इज इक्वल टू 10 स्क्वायर उसके हिसाब से, ठीक है, दैट इज 0.8। तो टॉर्क कितना लिखोगे, F इंटू 0.8, mg नीचे लग रहा है, mg का डिस्टेंस कितना है 0.6 विच इज ऑलरेडी गिवन टू अस, तो माइनस mg इंटू 0.6 और टोटल हो जाएगा 0। तो f का वैल्यू आएगा mg इंटू 0.6 डिवाइडेड बाई 0.8। तो मास ऑफ द व्हील इज इक्वल टू 20 kgs, तो 20 kg व्हील का मास है, ग्रेविटी का वैल्यू उस पर 10 लगेगा, और फिर 0.6 और 0.8 को तुम 6/8 लिख सकते हो, तो 2 4 ज़ा 8, 2 3 ज़ा 6, 4 5 ज़ा 20, तो 5 3 15 10 150, 150 न्यूटन्स। The amount of force required to start the wheel or to just move the wheel over the block is 150 newtons. You might have had some experience with this when you try to run your scooty over a stone or something. So you try and you try to, like, you turn the accelerator a little hard and then the scooty just goes up. That is the minimum amount of force required to get this wheel over that block. समझ में आया? If you cannot provide that much amount of force, क्या होगा? The wheel will just stay there. It just cannot go forward. No matter how hard you, like, pull the accelerator, it will not cross forward. That's the first problem today. The good thing about this problem was that there was kind of a predefined axis of rotation. Unlike all the equilibrium problems before, this problem was just about to, like, start moving. So it kind of had an axis of rotation given to us. So we could solve it and we could find out an answer. Okay, next question. Let us say that there is a rod, and on this rod, two forces are acting. So let us say there is a rod. Okay, so this rod is pivoted over here. It can move about this point. You have already seen this symbol. This stands for a pivot. This is equal to 50 newtons, and you're applying a force of 100 newtons in this direction. This is equal to 100 newtons. And this angle over here is equal to 30 degrees. The first question that is being asked over here, what is the reaction force provided by the pivot? What is the reaction force provided by the pivot? What is the reaction force that is provided by the pivot? Okay. The next question is, if the mass of the rod is equal to 1 kg and its length is also equal to 1 meter, what is the value of alpha? What is alpha? The angular acceleration. So to solve this, you will have to find out the moment of inertia and you will also have to find out the torque. So this single question is basically like two questions. And then you will also have to divide it. Okay? Pause the video, give it a try. Or if you have already tried it by now, see that the length of the rod is equal to 1 meter. The mass is equal to 1 kg. So the moment of inertia is equal to 1/12. How? Because this is the axis of rotation. If you remember, a pivot is a point that cannot move, but the rest of the rod can move about that point. So 1/12 m into L squared, so which will be equal to 1/12 kg meter square. Next, you want to find out the reaction force. The pivot is not going to move, so you can take the rod as a point mass. On this rod, there are two forces that are acting. The given forces, which is your 50, and the other force is acting at an angle of 30 degrees to the horizontal in this direction, which is 100. ये angle तुम्हारा 30 degrees है. अब इसके addition में there is going to be some reaction force at the pivot. The reaction force will have two components. It will have a y component. It will also have an x component. Because all in all, the rod has to stay at rest. ठीक है? There is an x component and there is a y component. अब तुम्हें ये चीज़ करना बहुत अच्छे से आता है, तुम आराम से कर सकते हो. You can just simply say that plus rx minus 100 cos 30 is equal to 0. तो आर एक्स का वैल्यू कितना आ जाएगा? आर एक्स का वैल्यू आएगा 100 इंटू कॉस 30 विच इज इक्वल टू 50√3. और तुम y के लॉन्ग लिखोगे तो वो भी तुम्हें आता है आर वाई माइनस 50, और यहाँ पे 100 का साइन 30 भी आएगा, तो प्लस 100 साइन 30 इज इक्वल टू 0. कैसे? 100 साइन 30 है ना इसका वर्टिकल कॉम्पोनेंट. तो आर वाई इज इक्वल टू 0. आर वाई हैपन्स टू बी 0. So the reaction force at the pivot, like we have it, is purely in the x direction and it is equal to 50√3 newtons. Got it? So the reaction force at the pivot happens to be in the x direction and it is 50√3 newtons. We have solved the first question. Okay? Now, let me erase all of this. Let us try to solve the second question. I have already found out the moment of inertia. That's there on the top of the screen. All I need to do is to find out the torque on this rod, and then I will have my answer. So what is the torque on the rod? Why is the rod rotating? The rod is rotating because of these two forces that are acting on the rod. Okay? So this 50 Newton force is acting. It wants to rotate the rod as shown. Let's say that is positive. The 100 Newton force is acting and that also wants to rotate the rod in the same direction. So that direction is also positive. Think of a steering wheel. If you're confused, think of a steering wheel. Both of these directions are the same. Even if the arrows look like they're in opposite directions, the direction of rotation is the same. अब बचा ये कि तुम्हें निकालना है रेडियस कितना है. तो रेडियस r is equal to 1/2 meters. So you can say torque is equal to plus r. R is equal to half. F is equal to 50. तो plus half into 50. यहाँ पे भी सेम चीज लिखोगे. तो r is equal to half. And what is f? F is the vertical, this component which is perpendicular to r. So you can write 100 sine 30, which is equal to again 50. If you don't want to write it like that, you can simply take r in the horizontal direction. So you do one of the two things, don't do both. So r is in the horizontal direction. Take the value of f directly, which is equal to 100, and take the angle between them, which is equal to 30. So you can write sine 30. So this is your torque. Torque is equal to r cross f, which means r into f into sine 30. So you can do whichever one of these two that you like. Okay. You can either write r into f sine 30, or you can write r sine 30 into f, or you can just write r into f into sine 30. All will give you the same answer. So you'll get 50/2, which is just equal to 50. So what is the torque? Torque is equal to 50 Newton meter, of course. And what is this? That is kg meter square. Now finally you want to find out alpha. So alpha is equal to tau divided by I. So what is tau? We found out tau is equal to 50. What is I? We found out I is equal to 1/12. So this will be 12 5s are 60, 600 radian per second square. That is the angular acceleration of the rod at this instant. समझ में आया? ठीक है? So this is how you calculate a problem where there is like, the angular acceleration is required. Let's say this is your second question today. Just practice a little bit about finding torque. Now torque is defined as r cross f, but in very few problems you will be used to you will be requiring the vector application of r cross f. Though I'll still give you a question today just to show you how to do the vector application. In most cases you will be dealing with components, which is why I emphasize a lot on the components rather than emphasizing on the mathematical aspect of it. So let's try another one. Let us say that a rod is pivoted at the origin. So there are three axes. Now this is kind of like a 3D figure, so I cannot exactly draw this thing. So I'll try to do my best. A rod is pivoted at the origin, and the other end of the rod is fixed at 117, some random number. Okay. At that point, a force is acting on the rod, which is given by, let's say, 2, 1, 4. That's your force vector. This is your R vector. Now, what is the torque acting on this rod? About the origin, or yeah, what is the torque acting on this rod? About the origin, about which this rod is going to rotate. So when you try to find out torque, what you normally do is you find out the perpendicular distance from the axis of rotation and all that stuff. That is not going to work over here simply because everything is given as a vector. I'm not saying you cannot find, you can find out all those values, but it'll just be very hard to do it. So what I suggest you do is you follow the vector application of torque. So torque is equal to R vector cross F vector. So I gave you this problem just to revise this thing for you. How do you find out a cross product? You find out a cross product by writing out a matrix like this. Okay. In the first line over here, you put down all the values of the first vector, which is R. The first vector comes on the first line. The second vector comes on the second line. So this is always your second vector. And then you do matrix multiplication. You must have studied some part of this in your vector chapter. So there R is 1, 1, 7. F is 2, 1, 4. And then you do the vector calculation. So what will you write? Torque is equal to I cap. Okay, if you did not know this, I am assuming that you know it, but still I'll solve it for you. You write I cap. And then you block out these values. You just remove these values. Don't consider them. You multiply 1 with 4. So you'll get 4. And then you multiply 1 with 7 but with a minus sign. So you'll get 4 minus 7. समझ में आया? Simple process है. It's not very complicated. जिस चीज को सॉल्व कर रहे हो उसको ब्लॉक कर दो. So you completely you block out that thing. Sorry, ठीक है? You block out 1 and 2. Don't use 1 and 2. 1 into 4 minus 1 into 7. ठीक है? So what we'll do is we'll apply this to all the remaining ones and then we'll solve and find out what is the cross product. So ये हो गया तुम्हारा I cap minus J cap. ठीक है? I is plus, J is minus, K is plus. Again block out J. So you'll get 1 into 4 minus 2 into 7. And then finally you'll have K cap and then you'll have 1 into 1 minus 2 into 1. So 4 minus 7 is minus 3 I cap. 4 minus 14 is minus 10, but that becomes plus 10 J cap. And 1 minus 2 is minus 1 K cap. So this is your value of torque. That's a vector quantity. Okay? It's an artificial problem where the R value and the F value are given as vectors. So if something like this is there, then you will have to use the vector cross product. Otherwise, you always use the component method and you try to solve using those things. Understood? Let's give you another problem. You'll basically learn by solving lots of problems because the formula is tau is equal to I alpha. So I can only teach you these things by giving you lots of problems. Try another one. So let us say there are four forces that are acting on a rod. So there is a rod and there are some forces given to you. This is a very big rod and there are some forces. So there is a force F. There is some other force over here. So this point is 20 centimeters. This point is 40 centimeters. There is a point at around 60 centimeters and there is a point at around 80 centimeters. All of these forces, they happen to be equal. What force is required at 80 to keep the rod at rest? Okay? To keep the rod at rest, to keep the rod at rest, find the value of x. Find x. So how would you solve that? One thing you would do is you would say that these forces are making the rod rotate like this. There are four torques over here. इसके आगे, it is already given to you, this is a pivot point. Even if the triangle is not drawn, a point like this with like a circle with a dot is a pivot point. So this is your axis of rotation. And all the distances are obviously, like you as a hint, they're given from the axis of rotation. So it should be easy for you to imagine this. So you can go ahead, pause the video and give it a try. Okay. So what will you do? Choose some direction as positive. Let's say this direction is positive. Then you start writing all the torque. So the first torque is going to be negative, minus 20 into F. The next torque is going to be positive, so plus 40 into F. The next torque is going to be negative, so minus 60 into F. The last torque is going to be positive, plus 80 into X is equal to 0. So you can write 80x is equal to 60f plus 20f, which is equal to 80f minus 40f, which means that x is equal to f by 2. Okay, so whatever the value of force, the force that you require to keep the rod at rest is equal to f by 2. Another question. So this was a question on rotational equilibrium, but in these questions the axis of rotation is predefined. It is given to you, so you can solve it directly. Try another problem, and this will probably be the last problem on torques and axis of rotation that I'm giving you. We'll start doing problems on rotational dynamics right now. So let us say there is a rod. Okay, so try this problem on your own, and on this rod a couple of forces are given. So there is a force over here of around 60 degrees and around 90 newtons. Okay, over here there is a force at the midpoint of the rod. Let's say that's around 60 newtons. Okay, and that's perpendicular to the rod. Towards the end of the rod there are two forces. There is a force pulling on this rod of 50 newtons, and there is a force that's acting in the backward direction, and that is around 70 newtons. This angle is equal to 60 degrees. The angle with the vertical over here is equal to 60 degrees. And even at the midpoint, let's put another force over here so that it looks a little bit harder. And this is around 30 degrees, and this is 80 newtons. Okay. And let us say the rod is pivoted at the end. This is where the rod is pivoted. Let's make this a homework question. I'll not be solving this question. This question is for you. I've given you a very proper idea of how to solve this question over here in this one. Okay, so this is the same kind of question, except the problem was way simpler. Here the problem is a little bit harder. So you have to do the same two things. Find the reaction force at the pivot. Find the reaction force at the pivot. And the next thing is, I want you to find out the angular acceleration of this rod. Find out alpha. Okay? So find the value of alpha. How would you do it? As always, let us say at the pivot there is a reaction force Rx and there is a reaction force Ry. Okay, so there is a reaction force at the pivot Rx and Ry. You solve to find out Rx and Ry just using components of forces. Okay, and then finally, once you're done solving the components that way, you need to find out torque. So what you do is you choose some direction as positive. So let us say you choose this direction as positive, and then you write down all the torques using whatever method you like to find out the net torque, and then you find out alpha. To find out alpha, you'll require two more pieces of information. Remember that this is the midpoint of the rod. That's the midpoint. Let us say the rod has a mass of 1 kg, and just to keep things every simple, let's say the length is equal to 1 meter. It's a very standard problem. Just focus on finding out the net force, the first challenge over here, and the next one is to find out the net torque. So once you're done with both of that, you've learned things pretty well. Okay, this is a problem on rotational dynamics. Something is going to start moving. Now let's start doing problems on actual rotational motion. So problems on rotation. Let's start with basic problems. Imagine that there is a wheel. We have done this problem in the last class also. I'm repeating it just for the sake of revision. Imagine that there is a wheel, and this wheel is pivoted at the center, and there is a rope that is coming down from this wheel. This rope is pulled with a force of F. There is a rope coming down from the wheel, and the rope is pulled with a force of F. Let us say the moment of inertia of the wheel is I. I'm not going to give you any values, so that in a question when values are given, you can just simply solve it. The radius of this wheel is given as R, The mass of the wheel is given as m. All these things are given. Okay. So the mass is given, the radius is given, the moment of inertia is also given. So don't use half mr square or mr square, use I. We will always be interested in the question of what is the angular acceleration of this wheel. Majority of the problems in rotational dynamics are interested in what is the angular acceleration of something. There are obviously other kinds of problems, but this one is the first kind that you should study about. तो यहाँ पे angular acceleration हो क्यों रहा है? Because you're applying the force. This entire wheel is going to start rotating. So this force is obviously producing a torque about the center. So what I've drawn over here is the small distance r. Okay. So what is the torque? Torque is equal to r into f. तो ये r का वैल्यू कितना है? That's the radius of the wheel. F का वैल्यू कितना है? That is the value that's given to you, r into f. So what you will do is you will say that about the axis that is given, about the pivot, tau is equal to I alpha. Okay, initially you are learning, so write these words. Later on you can just straight away write because it's understood. So you can write RF is equal to I into alpha. This problem is extremely very simple. So you can write alpha is equal to R into F divided by I. ठीक है, सिंपल सा प्रॉब्लम है. What does this equation mean? इसका मतलब क्या है? If you increase the value of R, if you increase R, keep in mind that if you increase R, the torque will increase. So if the radius of the wheel is increased, then you will have a larger twisting effect. At this point, the twisting effect is small, but if you increase the value of R, the twisting effect that you will have is going to be larger, which means that you will have a stronger rotational effect on the wheel. The wheel will rotate harder or faster. Okay. What will happen if you increase F? Obviously, the amount of torque is also going to increase. So increasing R or increasing F is going to speed up the wheel. Both of these, increasing them is going to speed up the wheel. It is going to increase the acceleration. If you reduce R, it is going to slow down the acceleration. If you apply a force right at the pivot, there is going to be no acceleration at all because this force is not going to have any rotational effect. Okay? What about the moment of inertia? The moment of inertia is basically the weight of that wheel, how heavy that wheel is feeling to you when you are rotating it. A wheel is a wheel. But if you try to, like, if you have any experience with a discarded tire, जो कि गाड़ी में लगता है, so you take the tire and you try to lift it. That is the mass. Now you put the tire on the road and you try to kick it with your leg and you try to make it start rolling. That is the moment of inertia. So mass and moment of inertia are slightly different things. So if you're going to, like, reduce the radius of the wheel and all that stuff, the moment of inertia is going to change. So if you reduce the radius of the wheel, I is going to decrease, and as a result of that, the angular acceleration alpha is going to be greater. If this seems absurd to you, think that reducing the radius means that you're making the wheel smaller, and a smaller wheel is easier to rotate. Okay, so I is inversely proportional. So decreasing I is basically going to increase your alpha. So I hope you understood this equation. You got a feel for this equation. समझ में आ गया होगा तुम्हें. It's a very simple problem on rotation. My key thing over here was to show you how to draw things and how to write an equation. Let's give you the next kind of problem. Let us say everything is exactly the same. We're going one step ahead. There is a wheel like this. So in problems in books, you'll not see a wheel. They'll say that there is a pulley with mass. Okay. Pulleys were massless so far. So these are pulleys with mass. And from this pulley of mass m, moment of inertia I, and radius r, okay, the radius of the wheel is equal to r, we are hanging a separate mass. We are hanging a mass. The question over here is what is the angular acceleration of this pulley? What is the value of alpha? Can you think about what we are supposed to do over here or how to proceed? See, first of all, if the mass falls down, the mass can only fall down, right? Because the mass is weight, the mass is going to fall down. So when the mass is going to fall down, the pulley is going to rotate. कितना rotate करेगा? This is a length. That same length was already wound up over here. So when the mass falls down, this length is going to unwind and it is going to come over here. Can you imagine this? This length of thread was already wound on the wheel. So जैसे ये mass गिरेगा, the pulley is going to rotate and that mass is going to come on the string. So we can basically say that when the mass is unwinding, the amount through which the pulley is rotating is the same. जितना mass गिर रहा है, the length through which the mass is falling down, the pulley is also unwinding through the same length. The mass is falling down through a length L and the pulley is unwinding through the same length L. Both of these are exactly same. But what is L for a pulley? R theta. L is equal to R theta. So if you divide by time, you will get velocity. If you divide by time once again, you will get acceleration. So we can basically write that A is equal to R alpha. This equation means that the falling acceleration of that mass decides how fast the pulley is going to rotate. मतलब मास जितना तेज नीचे गिरेगा उतना ही तेज पुली रोटेट कर सकता है. Both of them are basically proportional to each other. So if you have the mass falling down very fast, you can imagine in your head the pulley is like, rotating very, very fast and the rod is like, the rope is coming off. Okay. तो ये होने वाला है. A is equal to R alpha. That's your first equation. Second thing, we need to draw a free body diagram. So what is a free body diagram? You remove everything that is not essential to you and then you start drawing the forces on the problem. So what are the forces acting on this thing? So you will have force over here, tension. Same tension acts over here. You will have mg acting in the downward direction. इसका भी mg है, इसका भी normal force है pulley का, लेकिन वो किसी काम का नहीं है because the pulley is not moving, the pulley is rotating. So what kind of motion do we have over here? Linear motion. So you will write plus mg minus t is equal to ma. That is for linear motion. ठीक है, first equation. So why did I write plus mg? Because it matches with the direction of motion. Why did I write minus t? Because it's opposite to the direction of motion. So plus mg minus t is equal to m into a. That's your first equation. Okay. Second one. Because the pulley is rotating, there is a torque. Do you see the tension is providing the torque? So you can write plus r into t, the torque because of the tension, is equal to I into alpha. This is about the rotation, and that's your second equation. What do we want to do? Want to find out alpha, we want to find out A. Whichever one you find out, it's okay. So one way to do that is to take tension from here and to substitute it over there, or to take tension from there and substitute it over here. Same thing, but I'll take it from the second equation. T is equal to I divided by R into alpha. Let's put it in the first one. So you will get mg minus I alpha divided by R is equal to ma. Now you choose. What do you want to find out? If you want to find out alpha, I'll replace A with alpha. Okay, A is equal to R alpha. And if you want to find out A, then I'll replace alpha with A by R. Whatever you want to do. Okay. So if you want to find out A first, which is what I am going to do. So what I'll do is instead of alpha, I'm going to put alpha is equal to A by R. Alpha is equal to A divided by R. So I'll write mg minus I divided by R into alpha. Alpha is equal to A divided by R is equal to ma. Now I'll move this term towards the right side. So I'll get mg is equal to ma plus I divided by R square into A. So what is A? A is equal to mg divided by m plus I by R square. That is my value of A. So if you wanted to find out alpha, alpha is just A by R. So you will get mg divided by R divided by m plus I divided by R square. तो इसका मतलब क्या? What does it mean? So it means this, that when this block is falling because of its weight. And this weight is not only causing this mass m to move, it is also causing this moment of inertia I to rotate. So because of that, the acceleration is, the force that is causing it is mg, and the things that it is making to move is m and I by R square. So the acceleration is equal to mg divided by whatever is moving. So mass m is moving, the pulley is rotating, so m plus I by R square. So writing it like this is a very good way of understanding what's happening, but you cannot solve a problem by saying that ठीक है ये force है और ये move कर रहा है तो मेरा acceleration सीधे इतना हो जाएगा. You can kind of do this, but after you get a lot of practice. Okay. So right now, this is how you write the equations. I've written the arrows and circular arrows. That's what I do when I solve. But you can not do it also, as long as you can just write that this is because of linear motion and this is because of rotational motion. तो जब तक ये सब चीज तुम करोगे तो तुम आराम से you can solve a problem like this one. So most of rotational motion is about problems like this, where there is a mass, there is some kind of a pulley arrangement, and something is falling, moving, इस टाइप का कुछ ना कुछ होगा. ठीक है, तुम्हें समझ में आया how A is equal to R alpha? This equation is kind of important. Did you understand? The amount through which the mass is going to fall, the pulley is also going to rotate through the same amount. So this R theta is equal to this L, or this acceleration is equal to R alpha. तो ये चीज बिल्कुल क्लियर होना चाहिए. ठीक है, तो इसके आगे तुम आराम से सॉल्व कर लोगे. There is not much difficulty. Get some practice. Show you another problem. In this problem, the thing that is rotating and the thing that is falling, both of them, they are the same thing. They are the pulley. So there is a wheel that is hanging from a rope. What is going to happen if you release the wheel? Because of the weight of the wheel, this wheel is going to have a weight. Because of the weight of the wheel will want to fall down. Okay. Lekin because it is tied to a string over here, the wheel is going to start rotating. So the wheel will basically rotate because of its weight. It is going to rotate because of its weight. What we need to do is apply the same kind of logic like this problem. Something is rotating, something is falling, to this problem and try to solve it. ठीक है, सबसे पहला चीज, let's draw a free body diagram. So this is your wheel and this is tension acting on it and this is the weight acting on the wheel, mg. Because of this, what is happening? The wheel is going to fall down with an acceleration of a. Because it's also tied to a string, it is going to have an angular acceleration alpha. अब जितना वो नीचे गिरेगा उतना ही उसका अल्फा हो सकता है, that is r. ठीक है, a is equal to r alpha. Let us say the moment of inertia of the wheel is I, and like I've written, the radius is equal to r, and the mass of the wheel is m. Now you can write two equations. One equation will be for the vertical motion of the wheel. तो तुम क्या लिखोगे? Plus mg minus t. Why have we written plus? Same direction. Why have we written minus? Opposite direction. Is equal to ma. That is for the vertical motion, and that's your first equation. Now, what is the axis of rotation? The axis of rotation is this point, but as the wheel rotates and falls down, this point is going to keep changing. So maybe initially the wheel was over here at some point of time. That was the point previous time. As the wheel came down, different points became the axis of rotation. So here the axis of rotation is constantly changing. In such a case, what we do, we take the center of mass as the axis of rotation. जब axis of rotation बार बार change हो रहा है, या अगर कोई axis of rotation है लेकिन it is not very clear to us, we can always take the center of mass as the axis of rotation. So the center of mass of the wheel, this one is my axis of rotation, and I can see that torque is providing, the tension is providing a torque, whereas weight is not going to provide any torque. So I will write plus RT. Why plus? Because that is the angular acceleration. So plus RT is equal to I into alpha. That is for rotation. Second equation. समझ में आया center of mass क्यों लेते हैं? Because यहाँ पे axis of rotation बार बार change हो रहा है. ऐसा भी हो सकता है कि the axis of rotation can keep changing. So in a case where the axis of rotation is constantly changing, we cannot take that point as the axis of rotation. We actually can, we can still do that, but it is better to take the center of mass as the axis of rotation and then write RT is equal to I alpha. ठीक है, समझ में आया? अब क्या करेंगे, यहां से टेंशन लेके फर्स्ट वाले इक्वेशन में डाल देंगे. सो वी कैन राइट mg minus what is the value of t? I alpha divided by r. is equal to ma. अल्फा कितना है? अल्फा इज इक्वल टू ए डिवाइडेड बाय आर. उसका वैल्यू यहाँ पे डालो. तो एम जी माइनस आई डिवाइडेड बाय आर इंटू अल्फा विच इज ए डिवाइडेड बाय आर इज इक्वल टू एम ए. समझ में आया? तो एम जी इज इक्वल टू एम ए प्लस आई डिवाइडेड बाय आर स्क्वायर इंटू ए. हाउ मच इज दैट? ए इंटू एम प्लस आई डिवाइडेड बाय आर स्क्वायर. So what is the value of A? A is equal to mg divided by m plus I by r square. तुम इसको भी समझना चाहते हो तो you can also understand this in exactly the same way as before. Because of the weight, two things are happening. The mass is falling and the same mass itself is rotating. So acceleration is equal to force divided by whatever is moving. So m plus I by r square. But keep in mind, this is not a way to solve a problem. This is a way to understand the problem. Basically, the force mg is causing the mass to fall as well as to rotate. That is why the acceleration is equal to fg divided by m plus I by r square. ठीक है, समझ में आया? Second simple problem. So there are problems like this. There are further problems like this in rotational motion where you'll be applying the torque to find out angular acceleration, to find out linear acceleration, and so on and so forth. So we'll see you in the next class with more of these problems. And the next topic after that is angular momentum. But you need to practice a few problems like this on your own. ठीक है, चलो.